Okay, we're going to see how to simplify rational expressions. Rational expression is basically a fraction that contains variables both on the numerator or the denominator, but especially on the denominator, sometimes alone. The main process to simplify rational expressions involve factoring. So if you don't know how to factor expressions, you need to learn that skill first. Make sure you check the videos that explain how to factor expressions. Well, once you know already how to factor the expressions, well, the process that you're going to follow is, first, you're going to factor both the numerator and denominator if possible. Then you're going to cancel any up and down repetition that you find. And if there are some remainders that are multiplications in there, then you multiply them, and that will give you a simplified rational expression. Okay, so let's see how to use this process accordingly as explained. Okay, so we have a rational expression in here, which is a fraction with letters both on the numerator and the denominator. It could also be only letters on the denominator still, but in this case we have both. So we need to try to simplify this thing. The first thing we're going to do is we're going to factor. Okay, we can use the method of factoring trinomials on both of them, and if we use that method, we would know that the first one, if we factor it, will be x plus 3 times x plus 2. The one at the bottom, if we factor it, it will be x plus 7 times x plus 3. Okay, so first step is done. We already factored. Then we're going to cancel any repetition that we find up and down. That means x plus 3. If we cancel them, we're just going to copy the remainders. Because there is no other multiplication up, you don't need to put parentheses because only x plus 2 is in there, so you don't have to put any parentheses. X plus 7 is the only one that is under the line, so I'm just going to copy x plus 7. Because there is no multiplication to do, that will be the end of the exercise. Most of the exercises of rational expressions are solved this way. So let's see another example. Okay, x squared minus 4 and x plus 2. So this part in here, we cannot factor it. It's already on its simplest form, so there's no way we can factor that. But this one, yes, we can factor it. If we use the method difference of squares, you can check the method on the videos about difference of squares. You know that we need to get square root of both terms, and we put them with plus and minus. So if we factor this using difference of squares, we will get that the answer is x plus 2 times x minus 2. Now the x plus 2 that is in here, well, we're just going to copy it because it's not possible to factor this. And we're going to cancel any up and down repetition that we find, in this case, x plus 2. Now, notice that we eliminated everything on the denominator. So what do we do with that when that happens? If the things that are down were all of them eliminated, that means you no longer have a fraction. You only have the answer, which will be x minus 2. There is no fraction anymore because we got rid of the things that were under the line. So that will be the answer. Okay? Sometimes this type of things happen. Let's see another example where the opposite thing might happen. Okay? We have on top 3x. There's no way we can factor this. So we're going to leave it like that. But in this other case, on the denominator, yes, we can factor because there is a repetition of things. So we can use the method that is known as greatest common factor. Check the video for greatest common factor and you're going to see how to do this thingy. Okay? So we see what is repeating on all of the terms under the line. What's repeating in this case will be the 3 because 6 is 3 times 2 and 15 is 3 times 5. So the 3 is repeating. Not only that, but also the x is repeating. If I take the 3 and the x from those terms, the answer I will get will be 2x plus 5. So once I factor, the next thing I'm going to do is I'm going to cancel any repetition. The 3 is repeating and the x is repeating. So I'm going to cancel those two things. Okay? Now that I canceled those things, I need to copy the answer, okay, unless there's a multiplication. But how are we going to copy this? You might think, we just copied 2x plus 5. No, because everything on top was eliminated, but not on the bottom. So when you eliminate everything on top, you always need to put an invisible one that is always multiplying these things. You always need to put a 1 on top if you eliminated everything. Now at the bottom, you're going to copy what survived at the bottom. At the bottom, we have 2x plus 5. That will be the denominator, right? So the final answer for this thing will be this. Notice the difference that in this case, we cannot just put the answer. We need to put an invisible one that now is visible. But when the bottom is eliminated, we don't have to put anything. So that's the difference between eliminating the bottom or eliminating the top, either numerator or the denominator. So always be careful with that thing. Another example. So in this case, what we have in here is a 4 terms polynomial. This thing can be factored using a method called grouping method. If you remember grouping method, or if you don't, check the videos related to grouping method. And this one we can factor it using difference of squares. Those are the two methods that we're going to use. So use them, okay? You're going to have to leave an evidence on your notebook. I'm not going to do that, okay? But you leave the evidence of the process that you factor. So once you factor, the answers are going to be in here on top will be x minus 4 times 2x squared plus 1. If you use grouping method, you're going to see that's the answer you're going to get. Down, we're going to have x plus 4 and x minus 4. If you use difference of squares, you're going to notice that's the answer you're going to get. Once we factor it completely, we're going to cancel whatever is repeating up and down. That will leave us with 2x squared plus 1, which we cannot factor that, divided by x plus 4. And that will be it. So that will be the answer for this exercise. Okay, it might look really similar, but you need to take your time to factor these things on your notebook. So it's a little bit longer than what it looks in here. So another example. This case, we can factor both of them using the method called scissors method. Okay, so we're going to have to use a scissors method process in both of them. If you don't remember how to do scissors method, check the video related to scissors method process. Okay, so factoring those two things, we will get the answers on top 3x plus 1 times 4x plus 3. At the bottom, if we factor using scissors method, we will get the answer 2x minus 5 times 3x plus 1. Maybe you got them in different order. It doesn't matter. Okay? But the parentheses are those. So once you factor, you're going to cancel whatever is repeating up and down. And the things that are left, if there's no multiplication to do, then you're just going to copy them without parentheses. If there were two things that are multiplying, then you're going to have to copy the multiplication and then multiply. In this case, we don't do it. There is no way we can factor these things. They are already on its simplest form, so we're going to leave it like that. That will be the answer of this example. Let's take a look on another example. Okay, this one. How do you factor this? Well, we can use greatest common factor to factor this thingy, and also greatest common factor to factor this other thing. Okay, so in greatest common factor, what we need to look for is things that are repeating in all of the terms. On top, we know that the 3 is repeating and also x squared. At the bottom, the x is repeating. So those are the things that we're going to use in order to factor. We're going to take those things from them. If I take 3x squared from both terms, I'm going to have x left in here, because if I take the 3, goodbye to 3. If I take x squared, that means I take 2 of the x's. But there are 3 in here, so 1 is going to survive, right? In the other one, if I take 3x squared, it might look like if I took everything, but remember there's always an invisible 1 multiplying. So there's going to be a minus, the minus it stays, and the invisible 1 that now is going to appear. At the bottom, if we use the same process, we take the x, that means we would have x squared minus 1. Okay? Now, you might think this is all we can do, but this parenthesis can be factored again. So we're going to factor it a second time. Only that in this case, we need to use the process of difference of squares. So we're going to do that process. By following that process, we just need to get square root of those things. So we're going to do it. Okay? So we're going to have 3x squared x minus 1 in there. That's already factored. And at the bottom, x squared minus 1 can be factored into x plus 1, x minus 1. Once we have factored everything completely, now we're sure that we've factored everything, we can cancel any repetition. So the x minus 1 is repeating, but also this x is repeating with one of the two. So I'm going to cancel with this square to explain that I cancel it with the second x. The first x is going to survive, but the other x won't. Okay? So now that we have this, we're just going to copy the things that are left. The 3 survives. The x, one of the x's, survives. Nothing else on top. At the bottom, the x plus 1 is the one that stays there. So that will be the final answer because there is no other multiplication to do. Let's see another example. In this case, the things that we have, they look kind of like similar. The problem is that they're not ordered. So we're going to try to organize this. Okay, the letters first, then the number. The letters first, so it will be like this, and then the number. Okay, now that we organized this, we can tell that they're not the same thing. So we cannot like just cancel. No, that's not possible because they're different. So what should we factor in here? It looks like we cannot factor anything, but actually we can. If we use greatest common factor in here, we can take the minus, not a number, not a letter, the sign minus. If we take the sign minus, all we need to do is change the sign of each one of the terms. So it's going to happen this way. We copy the one on top, and at the bottom we take the minus. When you take a minus using GCF, what you need to do is change the signs of all of the terms inside. So it's going to be 2x in here, and instead of positive 7, it's going to be negative 7. I changed the sign of both of them so that I can take a minus. Why? Because, well, that is going to make me get this thingy. Minus times 2 will be negative 2, and minus times minus is going to give me the plus. So it makes sense. Okay. Now that we factored the minus, we can tell that there's something repeating up and down. That's what we're going to cancel. Now, in this case, something interesting happens. We canceled everything, right? So what do? Well, there's a minus that survived at the bottom. So what do we need to put when we canceled everything? Well, remember, there's always an invisible one that is multiplying the whole thing. So we can copy the invisible one up and down so that we know what survived. Okay, so we put a 1, or like a normal 1 in here, over the negative, right? But we cannot just put a minus, so we need to put something, the invisible one, right? So in this case, what survived was 1 over negative 1. That is a division that you have to do. 1 divided by negative 1 is negative 1. So the answer in this case is no longer a fraction, it's a normal number. Weird example, but sometimes stuff like that you might find them. A final example. Okay, so we've been talking about the final step, that you multiply whatever is left, but we haven't multiplied so far. So we're going to do an example where that happens. Yes. So the top can be factored using grouping method. Okay, and the bottom can be factored using factoring trinomials process. So if you don't remember those processes, check the video that explains how to use those processes. Okay, so if we factor that, what we're going to get is, on top, we're going to have x plus 3 times x squared minus 4. Yes, over, at the bottom, we're going to have x plus 2 times x plus 2. Now, it might look like there's nothing to cancel, but this x squared minus 4 can be still factored a second time if we use the difference of squares process. So we're going to do that. We're going to factor that parenthesis. We're going to copy the rest. So we're going to have on top x plus 3 times x plus 2 times x minus 2. So we have 3 parentheses in here, because this x plus 2 and x minus 2 comes from the x squared minus 4. The ones at the bottom, you just copy them. X plus 2, x plus 2. Now we know that something is repeating up and down. The x plus 2 is repeating up and down. I'm only going to cancel it once, because in order to cancel it a second time, there should be a second x plus 2 to cancel with. But that's not the case, so we're not going to do that. We're just going to cancel it once. Now, if we cancel it only once, you're going to see that on top now we have 2 things that were not canceled. So how do we copy them? We have to copy them using parentheses because they are multiplying still. So I'm going to put them inside parentheses. Now at the bottom there's only one thing that survived, so I don't need to put parentheses on that thing. Now this will be the normal process. You factor, then you cancel. The last step is that you multiply if there is something that you have to multiply. In this case, this 2 parentheses. So you're going to do a process, a separate process, where you're going to multiply. Okay, same as you factored. You're going to multiply this thing using distributive property. Yes. So you can do that on your notebook somewhere else. And once you find the answer, you just copy the answer of the multiplication in here, which would be x squared plus x minus 6 divided by x plus 2. That will be the final answer of this exercise, because there's nothing else that you can cancel. So that will be the final answer for this. So there are a lot of techniques that we're going to have to use. Sometimes we're going to have to factor twice or factor a negative or combine different methods of factoring, but we're always going to follow the initial 3 steps. We're going to factor the expression always. We're going to cancel any up and down repetition that we find, and if there are remainders that we can multiply, sometimes we're going to multiply them. That's the process that we use to simplify rational expressions.